Today we're going to look at relative risk, odds ratio, and rate ratio. To start, we're going to look at some basic definitions. Here we have rate, which is defined as the number of cases over the population at risk within a given time frame. Next we have ratio, which is the numerator over denominator that does not contain the numerator value. Risk is defined as the chance of developing a disease over the condition, and odds are expected probability of exposure or infection. We can use ratio and odds interchangeably. Some more complicated definitions that we'll get into further as we move through this lecture are incidence rate, which is defined as the number of new cases among those at risk of the disease over the given time period. Relative risk describes the outcome associated with predictors that are being evaluated. And last, we have odds ratio, which describes associations emerging from case control studies and also describes frequencies of data. Speaking of data, we're going to look at some right here. We're going to go over risk, odds, and rates. To calculate risk, you divide the number of individuals who drink heavily and do have stomach cancer, which is a value of 18, over the total population being studied, which is 500. If we go back to our basic definitions, you can see here that rate is the number of cases over the population at risk within the given time frame. And that's what we see here in risk of cancer for heavy drinkers, which has a value of 0.036. To calculate risk in those who do not have cancer, you would divide those individuals, which is 2, by the population being studied, which again is 500, where you get a value of 0.004. To calculate odds of getting cancer in those who are heavy drinkers, you would divide that population by those who are heavy drinkers but do not have cancer, which is a value of 482. To calculate the odds of getting stomach cancer in those who do not drink, you would divide that population of 2 by those who do not drink and do not have cancer, which is 498. And you get a value of 0.004. Moving on to rate, to calculate the rate at which heavy drinkers may get cancer, you divide that population of 18 by the person time of 985, and you get a value of 0.018. To calculate the rate of stomach cancer in individuals who do not drink, you divide that population 2 by the person time value of 1000, and you get a value of 0.002. For the purposes of this lecture, we will only be looking at the city of Atlantis, and as you can see so far, the risk, odds, and rate of getting stomach cancer is higher in heavy drinkers than it is in non-heavy drinkers in every incidence. Moving on, we'll look at relative risk. Here you can see the relative risk formula. Using a 2x2 table of data, you can fill in the formula to find your result, which in the case of Atlantis, the relative risk of getting cancer is 9. Which means those who drink heavily are 9 times more likely to get stomach cancer than those who do not drink heavily. Next, we'll look at the odds ratio. Here's another formula which you would use the 2x2 table to populate the AD over BC to get your final result. In Atlantis, the odds of getting stomach cancer are higher for those who do not drink heavily, significantly. Rate ratio, which is also incidence ratio. You can see here is the number of new cases of disease among those at risk in population over a given time period. This whole value is over person time followed over the same time period times a multiplier. In the city of Atlantis, we have 0.018 over 0.002, which equals 9.13 per 1,000 person years. And lastly, we'll cover the relationship between odds ratio and relative risk. Odds ratio can provide a decent estimate of the relative risk in certain instances. For example, when looking at rare conditions, the reason that this works with rare conditions is because the population with the disease are so minute relative to the non-disease population that the difference becomes negligible. We can also we can also use odds ratio for relative risk when controls represent individuals of the base population and when cases represent individuals in the base population of those within the disease of interest. I hope this basic overview of relative risk, odds ratio, and rate ratios helps you better understand how to calculate these. Thank you.